Today we're going to be completing a titration, and the purpose of the titration is to determine the concentration of it in a reaction. You can also determine the electrons gained or accepted in a redox reaction if you're working with a redox reaction, or you could determine the solubility products in the reaction. But in this case, we're going to determine the unknown concentration of a solution of NaOH, which is going to be the analyte. And we have potassium hydrogen phthalate, which is going to be the titrant, which is a known concentration. So in order to do a titration, you have to know the concentration of at least one. So here, like I said earlier, we have unknown concentration of sodium hydroxide, and we have the concentration of KHP known. So what we're looking for, we want to find the analyte molarity. And what's really important, you have to know how to record the volume on a burette. So this is a burette. It starts at 0 milliliters and it contains total 50 milliliters. The way we determine volume is called volume by difference. And what you're going to do is you're going to have an initial reading and you're going to record it in your notebook, and then you're going to allow the solution to run out until the solution turns pink, and I'll explain that in just a minute. And then you're going to have a final volume here, and that's going to be your final volume that you're going to record in your notebook. And what you want to do is you want to subtract your final minus your initial to give you the actual volume of the solution added to the titrant. So, and let me explain the equivalence point. Equivalence point is where you have your known concentration of your titrant, and you're going to add a couple of drops of phenolphthalein. And you can, the thing about the phenolphthalein, it tells when the equivalence point is reached, which is when the moles of the titrant is equal to the moles of the analyte. So what you're going to do, you're going to keep adding the analyte into the titrant until you see like a faint pink color. You don't want it to be too pink because you've gone too far. So what you're going to do, you're just going to add it, you're just going to allow the solution to flow into the Erlenmeyer flask, and then you're going to record the volume, and then you're going to do calculations to determine the moles of the unknown concentration and the known, and then you're going to use the known, and then you're going to divide it by the amount of analyte that you started with, and then that's going to give you the concentration of the sodium hydroxide. So I'm just going to get started. I already have my drops of phenolphthalein. So I'm going to start with 0 milliliters of sodium hydroxide, and I'm going to record that in my notebook here. So now I'm going to begin adding, and while you're adding, you want to kind of swirl it a little bit. In between, you may see some color changes. It may turn pink, but as you swirl it more, you're going to see that it's going to go back to clear, which means that it's going to approach the equivalence point pretty soon. So when you see these color changes, you're going to swirl until it becomes clear again. And then as you see these color changes occurring more and more frequently, that means you're going to reach the equivalence point. So you want to start adding the sodium hydroxide at smaller increments. And we've reached our equivalence point. So when you reach your equivalence point, it's going to be a really faint pink, and you can see it more closely on the paper. So we have the amount of sodium hydroxide that we started with, and now we're at, our final is going to be 40.6 milliliters. So in order to determine the actual amount of sodium hydroxide that we added to the acid, you're going to take the final and subtract the initial 0.0406 liters